Travis has made a great video on how to use the rotary evaporator, and I am going to, or Travis will show you how to use the rotovap, okay? This week we're going to train you, but after this we expect you to be proficient, and using the rotovap will be one of the techniques that you could pull in your final technique check. The theory behind the rotovap is basically the same as a distillation, which is why we can kind of substitute this out, except it's actually faster than doing a distillation, yet another perk to having this piece of equipment. But the rotovap does take advantage of some of the gas laws you learned about in general chemistry, particularly those as to what happens when you apply a vacuum, and what happens to the boiling point of solvents when you apply a vacuum to the solutions. Travis in his video has told you to clean the bump trap if your sample does bump, and we discussed bumping in our distillation labs. That same thing can happen in rotovapping. If that happens and you end up getting solution into this kind of shared bump trap, let me know. I will help you recover your product, and I will clean the bump trap. Bump traps are kind of specialized glassware, so they are expensive, and we don't have a whole lot of them sitting around. So I don't mind cleaning this piece of glassware for y'all. Once you have removed all of your dichloromethane from your small round bottom, and that will be collected in a flask that's attached to the round bottom, you're going to let your flask cool, because we'll have our water bath for the rotovap set maybe around 40 or 50. We really don't need it very high. Dichloromethane pulls off quite easily on the rotovap since it does have a low boiling point. Once the flask is at room temperature, which should not take very long, you need to obtain its mass so that you can figure out how much clove oil you actually isolated. You are collecting an oil, so there's not going to be a whole lot. There shouldn't be a lot of liquid. It should be a thick solution, or really not a solution. It should be a thick oil at the bottom of the round bottom. And that's why I said you'll be able to clearly see if you accidentally transferred any sodium sulfate. You'll see little crystals at the bottom, and eugenol does not really crystallize. It remains in the oil state, especially at room temperature, which is what temperature we'll be dealing with it at. At this point, once you have collected your mass, you need to dissolve your clove oil in 10 milliliters of methanol for the next steps of the lab. If you don't, you will not necessarily get some of the results that you should expect. So the next steps, and your lab book actually has you jump quite a few pages to your kind of analysis part of the lab. You're basically checking for double bonds in 3 separate tests, and then we're actually going to run a TLC plate, which we learned how to run last week. So for doing these tests that will check for double bonds, it's ultimately taking advantage of addition reactions, which we should get to towards the end of this semester, basically adding atoms across a double bond to get rid of a double bond and generate a single bond with new things attached to those carbons. For these tests, you'll need to get 6 test tubes, and 3 of these test tubes will be designated as controls, so you will not put the eugenol solution in those 3 test tubes. Your book discusses how to number them, and I follow that numbering as I go through the test here. You're going to put 1 milliliter of methanol in each test tube. You will add 5 drops of diluted clove oil, so the clove oil you just diluted in 10 milliliters of methanol, to test tubes 1 and 3. You're going to add 10 drops of your diluted clove oil to test tube 5. You'll want to mix these 3 test tubes by swirling to make sure that your eugenol mixes well with the methanol that you already had in there. The first test that your lab book takes you through is the bromine addition test, okay? You're going to add a 1% bromine solution drop-wise to test tube 1, okay? You're going to record observations after each drop is added and keep up with how many drops of bromine solution you need until your solution turns a pale yellow color and remains that way. You want to repeat this exact process with test tube 2, making the same observations, but of course test tube 2 is one of your control tubes that should not contain any clove oil. The second addition test is the potassium permanganate test. It's another addition reaction, adding things across the double bond, this time to alcohol groups. You're going to add 3 drops of 0.05 molar potassium permanganate to test tube 3 and record your observations. You will also add these 3 drops of potassium permanganate to test tube 4, but again, test tube 4, your even number test tubes, are your control tubes that do not contain that eugenol, or commonly called clove oil. Finally, our last test is actually a metal complexation reaction with iron 3 chloride. You're going to add 1 drop, sorry about that typo, 1 drop of 1% iron 3 chloride to test tube 5, which contains your diluted eugenol. You're going to record your observations and then repeat this process with test tube 6. And test tube 6, of course, was your last control tube that doesn't contain the clove oil. The last thing that they have you do is run a TLC plate. This is where it's especially important to make sure that you have diluted your clove oil, your eugenol that you isolated on the rotovap. You're going to spot a TLC plate and make 3 hash marks on that plate. 1 hash mark, the center one they suggest, should be the stock solution, and on either side you're going to spot your clove oil that you isolated. And again, they want you to kind of do the 1x and the 2 times spotting, so the 1x and the 2x spotting, to compare which one works best. You will develop your TLC plate in a chamber just like we've done in the past. This time you will be using a solvent system. 9-to-1 hexane to acetone will be our solution that we're mixing up, and that translates into 4.5 milliliters of hexanes to 0.5 milliliters of acetone. You will need to make that up on your own. We don't have this hexane acetone solution mixed. Once your plate has developed, again, do not let the solvent move all the way off the TLC plate. You will visualize your plate. I will once again have out the UV light and the iodine chamber. If for some reason the iodine chambers aren't out, that's okay. The UV is, to me, the best way for visualizing, but sometimes we do see extra spots if we get out the iodine chambers. You want to collect your data, qualitative and quantitative, so make sure to take your measurements in order to calculate retention factors for all the components of your solution. There's a note in your lab book that eugenol acetate will appear as a minor spot. It runs a little bit higher in this solvent system, and so you should have a bigger retention factor than your eugenol. And of course, we're having the stock solution of eugenol, so you should be able to figure out which spot is eugenol versus eugenol acetate. Sometimes eugenol acetate is, you don't have a lot of it, and so that's where the 2 times spotting really can come in handy for this particular lab. After you're done, I would get rid of your glassware and dispose of your waste correctly. Potential errors. Since we just spoke about the TLC plate, one error that I commonly see people doing, and some of you did this last week, people get rid of their spotting solutions too early, and then they can't rerun a TLC plate if something happens to it. Don't get rid of your sample, your clove oil that you've made and diluted with methanol, until you have seen your TLC plate and are happy with how it looks. Okay. Other common mistakes are not grinding the cloves well. If you don't grind the cloves well, you don't have the cloves interacting as much with the water. You don't have as much surface area. And so it's harder for that eugenol water azeotrope to form and, of course, distill off. Some people forget to add water and they end up creating kind of a sludgy situation in that 100 milliliter round bottom. That can be very difficult to clean and also doesn't allow for the azeotrope to form. So keep a close eye on that water level in that 100 milliliter pot. Oftentimes, as we have now seen in our simple versus fractional distillation lab, people will distill too fast, and that doesn't allow for the azeotrope to form and come off very effectively. Other mistakes after the distillation, a lot of times people will not label test tubes correctly, so you don't know what you've tested for, and you don't know which of the 2 test tubes are your control. And that makes it very hard to make observations and prove whether or not you've had a reaction with a double bond. I've already mentioned this, but another huge mistake people make is not diluting their clove oil, which of course we know is also called eugenol. If you do this, it will definitely overload your TLC plate and it will make you use up your sample very quickly. You do not have to do the addition reactions first and then the TLC plate. You can do those in reverse order. All of it's just analysis, but make sure to dilute your sample before you start any analysis. That way you have plenty of sample. If you're trying to add all the drops for the addition reactions with just the pure oil, you're not going to have anything left over for your TLC plate. Other common mistakes, especially with any TLC lab, is people forgetting to get their RF value data. In terms of waste, you want to always dispose of waste in correct containers. This week we'll have not only dichloromethane waste, which we've had in the past, but also these testing solutions will contain bromine and chlorine or chloride anions. And all of those, of course, are halogens that we need to put in our halogenated waste containers and keep it separated from our non-halogenated waste. Capillary tubes, of course, are glass, and so they'll go in broken glass containers. TLC plates, as you now know, are considered trash. With regards to getting rid of the clove and water mixture, you can pour that down the drain, and if you can try to collect the cloves so that we don't clog up the drains, the cloves can just go in the trash since we are literally using baking cloves. Good luck with the lab.